Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the exercise 8.3, question number 4. This question is having 10 parts. And if you want to practice more questions related to trigonometry, check out the link in the description. We are having the quiz specially related to trigonometric questions. Check the link in the description. And without taking any further time, let's start with this lecture. And best of luck, and here is the lecture. Question number 4 is, prove the following identities where the angle involved are acute angles for which the expressions are defined. This question is having total 10 parts. Let's take one by one. First is cosec theta minus cot theta whole square equal to 1 minus cos theta upon 1 plus cos theta. We have to prove left hand side is equal to right hand side. On observing, we found that on left hand side we are having cosec and cot. On right hand side we are having completely cos. So basically somehow we have to convert cosec and cot into the cos term. Let's see how we approach this question. Cosec we know is a reciprocal of sine, that is 1 upon sine theta, and cot theta is cos theta upon sine theta. Cot is a reciprocal of tan and we know tan is sine upon cos, so cot will be cos upon sine. Okay, let's replace the terms. Let's take sine theta as the LCM. We got 1 minus cos theta upon sine theta whole square. Here let's segregate the square term. It will be 1 minus cos theta whole square upon sine square theta. And we can write 1 minus cos theta whole square as 1 minus cos theta into 1 minus cos theta. Okay, it is square, so we have just written it 2 times. Why we have done that? Because in the right hand side in the numerator we are having 1 minus cos theta. By doing so we got 1 minus cos theta in the numerator. So it is matching. So we got the one expression, that is a numerator. Now we have to work to get the denominator, which is 1 plus cos theta. So this is the approach in which you should think. You should keep the expression of right hand side in your mind so that you can solve accordingly. Further, can we rewrite sine square theta as 1 minus cos square theta? We have simply used the first trigonometric identity. We got sine square theta as 1 minus cos square theta. And 1 minus cos square theta, it is resembling a square minus b square, which is a minus b into a plus b. This formula, that is a square minus b square, will be frequently used in this trigonometric identity. A minus b into a plus b, that is a square minus b square, or here it is a square minus b square, which will be a plus b into a minus b. This will be frequently used, so you should know this. Okay, so 1 minus cos square theta, we can write it as 1 minus cos theta into 1 plus cos theta. Now we have converted all the terms into the cos form, which is the right hand side. Here 1 minus cos theta in the numerator and denominator will cancel out. We got the expression as 1 minus cos theta upon 1 plus cos theta. That is the right hand side. So we have proved left hand side is equal to right hand side. A advice: do not blindly follow the steps. Just see what approach we are using. You may find the alternative approach. Just focus on the different approaches that you can use to solve the question. You could have also taken the right hand side expression and use a rationalization. A alternative form of approach, you can try it out. Here we have taken the left hand side and we have converted all the terms into the cos terms. And we have used the first trigonometric identity, which is sine square theta plus cos square theta is equal to 1. Rest is the basic mathematics. Got it? So we have done with the part 1. Let's go to part 2. Part 2, cos a upon 1 plus sine a plus 1 plus sine a upon cos a is equal to 2 sec a. Before solving, let's observe the expression. Observing the expression is very important as it decides which approach you have to proceed with. Here in the left hand side we are having the term with sine and cos. It means that somehow the first trigonometric identity, that is sine square theta plus cos square theta is equal to 1, will be applicable. How that will be applicable, that we will see in the course of the solution. In the right hand side we are having 2 times sec a, but in the first trigonometric identity we are not having the sec term. But we know sec is the reciprocal of cos. So right hand side we can write it as 2 into 1 upon cos a, which is basically 2 upon cos a. This is not the solution. I am just telling you what should be the thinking process in your mind to solve this question. What you should think while seeing this question. This will decide the approach that you have to use. So we got cos in the right hand side and sine and cos in the left hand side. And we also got that somehow we have to use the first trigonometric identity equation. Okay, let's solve this. Let's start with left hand side. Let's take the LCM as cos a into 1 plus sine a. On the numerator we got cos square a plus 1 plus sine a whole square. Further, let's open this square, that is 1 plus sine a whole square, which will be a plus b whole square. A square plus b square plus 2ab. So in the numerator we got cos square a plus 1 plus sine square a plus 2 sine a. Here sine square a plus cos square a, it is resembling the first trigonometric identity formula, that is sine square a plus cos square a is equal to 1. Okay, so in the numerator we got 1 plus 1 plus 2 sine a, which is 2 plus 2 sine a. Here let's take 2 as common. Further, 1 plus sine a is common in numerator and denominator, that will cancel out. So we got the final expression as 2 upon cos a, and 1 upon cos a, we know it is sec a. Sec and cos both are reciprocal of each other. So we got the answer as 2 sec a, that is the answer. Got it? The approach that we have used to solve this question. Do not blindly solve the question, just see what is in the right hand side. Then only proceed with the left hand side. Got it? So we have done with the part 2. Let's move to part 3. Part 3. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus sec theta into cosec theta. One hint is also given. Write the expression in terms of sin theta and cos theta. The hint is given very good, but every time the hint will not be given in the question. So let's proceed with this question. Firstly, let's observe the question. Here the expression on left hand side are tan and cot, and on the right hand side it is sec and cosec. If you observe the 3 trigonometric identities formula, the second formula involves tan and sec, and the third formula involves cot and cosec. On the left hand side we are having tan and cot. It means the second formula will not be completely applicable as it involves tan and sec, tan theta and sec theta. Here it is tan and cot. So the third formula will also not be applicable. Got it? So somehow we have to change this expression to the value where we can apply the trigonometric identity formula. That conversion is in the term of sine and cos. That is given in the hint. That is, write the expression in terms of sine theta and cos theta. On right hand side we are having 1 plus sec theta into cosec theta. Here also sec and cosec are involved, which are not directly linked through any of the trigonometric identity formula. Got it? This you should note that the first trigonometric identity formula involved the linking between sine and cos. The second formula involved the linking between tan and sec, and the third involved the linking between cot and cosec. Got it? Let's proceed. So we will convert the complete expression into sine and cos term, which is also the hint given in the question. On the left hand side we are having tan and cot. We know tan theta is sine theta upon cos theta, and cot theta is the reciprocal of tan, which will be cos theta upon sine theta. So we can easily convert the left hand side expression into the sine and cos term. Similarly, on the right hand side we are having sec and cosec. Sec is a reciprocal of cos and cosec is a reciprocal of sine. So on the right hand side also we can easily convert to sine and cos. So let's do so. Firstly, let's take the right hand side, that is looking simple. Sec theta, replace it with 1 upon cos theta. Cosec theta, replace it with 1 upon sin theta. So we got 1 plus 1 upon sin theta into cos theta. Okay, we have converted the expression into sin and cos. Now we will solve the left hand side, and our goal is to get the expression as 1 plus 1 upon sin theta into cos theta, which is the right hand side. So let's approach. Let's replace tan theta with sin theta upon cos theta, and let's also replace cot theta with cos theta upon sin theta. Let's solve it. Firstly, the denominator part. Let's take sin theta as LCM in the first expression and cos theta as the LCM in the second expression. So in the denominator, we got sin theta minus cos theta upon sin theta in the first expression, and in the second expression we got cos theta minus sin theta upon cos theta. Let's further solve it. Let's take the below term to the upper side. We got sin theta into sin theta upon cos theta into sin theta minus cos theta, plus in the second expression cos theta into cos theta upon sin theta into cos theta minus sin theta. Here sin and sin, it will be sin square, cos and cos, it will be cos square. Further, in the first expression it is sin theta minus cos theta, in the second expression it is cos theta minus sin theta. For similarity, let's take minus as common in the second expression. We got sin theta minus cos theta. We have done so that we can take the common term out of the expression. So let's take 1 upon sin theta minus cos theta as common. We got sin square theta upon cos theta minus cos square theta upon sin theta. Let's take sin theta into cos theta as the LCM. We got sin cube theta minus cos cube theta upon sin theta into cos theta. We got the cube term. Do not worry, we can easily solve this. The formula applicable will be a cube minus b cube, which is a minus b into a square plus ab plus b square. These basic formulas, the square formulas and the cube formulas, you should know. This will be frequently used in the trigonometric identity. So let's solve it. We got sin square theta plus sin theta into cos theta plus cos square theta. The benefit that we got from using the cube formula is that sin theta minus cos theta will cancel out in the numerator and denominator. And the second benefit we got is we got sin square theta and cos square theta, which is the trigonometric identity, the first formula, which is equal to 1. So we got two benefits from doing the cube formula. Whenever you got the cube formula in the trigonometric identity question, you should not worry, directly apply the formula and you will get the square term, which are the trigonometric identity formula. So that is basically good. Okay. So let's add sin square theta plus cos square theta will be 1. Further, we can split this expression. This and this term will cancel out. We got our final expression as 1 plus 1 upon sin theta into cos theta. That is the right hand side expression. We got left hand side is equal to right hand side. Slightly a lengthy one. We have also applied the cube formula. Slightly a twisted question, but a good question. We have solved with part 3. Let's move to part 4. Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. 1 plus sec a upon sec a is equal to sin square a upon 1 minus cos a. The hint is given, simplify left hand side and right hand side separately. So this is the question. Let's approach this question. Here the left hand side expression is given in the terms of sec, while the right hand side expression is given in the term of sin and cos. So let's try to convert the left hand side expression, that is the sec expression, into the sin and cos. Let's see. Here it is given 1 upon sec a upon sec a. And we know what is sec. Sec is the reciprocal of cos. Sec a is equal to 1 upon cos a. Let's replace the term. We got 1 plus 1 upon cos a upon 1 upon cos a. In the numerator term, let's take cos a as the LCM. we got cos A plus 1 upon cos A in the numerator. Here this cos A and cos A will cancel out. We got cos A plus 1 in the left hand side. So we have solved the left hand side. We got cos A plus 1. Now let's take the right hand side and let's try to solve it. This expression is in the term of sine and cos. And in the left hand side, we got our final expression in terms of cos. So let's try to convert this sine value in the term of cos. How we can do that? Here we will use the first trigonometric identity equation, that is sine square A plus cos square A is equal to 1. Here sine square A in terms of cos, it will be sine square A is equal to 1 minus cos square A. So let's replace sine square A. Further, here 1 minus cos square A is resembling A square minus B square, which is A minus B into A plus B. So we can replace 1 minus cos square A as 1 minus cos A into 1 plus cos A. Simply we have used the formula of A square minus B square, which is A minus B into A plus B. Got it? Further, here 1 minus cos A will cancel out with each other. We got right hand side as equal to 1 plus cos A. So our left hand side and right hand side are matching with each other. That is the answer of this part. Got it? We have done with the part 4. Let's move to part 5. Cos A minus sin A plus 1 upon cos A plus sin A minus 1 equal to cosec A plus cot A. Using the identity cosec square A is equal to 1 plus cot square A. So this is the question. Firstly, let's observe the question. In the left hand side, we are having the terms in sine and cos form, while on right hand side, we are having the terms in cosec and cot form. So how we can convert the sine and cos term into the cosec and cot? We know 1 upon sine is the cosec and cos upon sine is the cot. The same fundamental we will use here. Here we will divide the numerator and denominator of the left hand side with sine A. By doing so, we will get the terms in cosec and cot form. Let's see. So let's divide sine A in the numerator and denominator. Cos A upon sine A, it will be cot A. And sine will cancel out. We got 1. And 1 upon sine A, we got as cosec. So basically, we are successful in converting the left hand side into the cosec and cot. Further, let's solve this. And this is the tricky part. So pay your full attention here. What should be the next step? Should we use the rationalization or which approach we should use? Here we will use our third trigonometric identity, which is cosec square theta is equal to 1 plus cot square theta. On rearranging, we can rewrite this as cosec square theta minus cot square theta is equal to 1. Here in the numerator, we can replace this 1 with cosec square A minus cot square A. By doing so, we can further proceed with this question. Many times in the trigonometric identity question, you are left with the value 1 and you can play with this 1 using the 3 trigonometric identity. That is, you can replace this 1 with sin square theta plus cos square theta, or sec square theta minus tan square theta, or cosec square theta minus cot square theta. You can play with 1 in the different form. This is important. If you're not having any further way to proceed with the identity equation or the given equation, you can play with this 1 using the 3 trigonometric identity. Got it? Here we have replaced 1 with cos square A minus cot square A. Further, this is resembling A square minus B square, cosec square A minus cot square A square minus B square, which is A minus B into A plus B. Our same formula we have used multiple times. It will be cos square A minus cot A into cosec A plus cot A. Further, we can take cot A plus cosec A as common in the numerator. We got 1 minus cosec A minus cot A. Further, let's multiply this term with the minus. We got 1 minus cosec A plus cot A. Further, here these two terms will cancel out with each other. We got cot A plus cosec A, which is the right hand side expression. Got it? This is the answer, slightly a long one. But the important thing that you got from this question is that you can play with the number 1. which we have replaced here with cosec square A minus cot square A. This is an important understanding or the learning that you got from this question. Got it? So we have done with this part. Let's move to next part. Root of 1 plus sine A upon 1 minus sine A is equal to sec A plus tan A. So let's proceed with this question. Here in the root we are having 1 plus sine A upon 1 minus sine A. We are having the terms inside the root. So firstly let's take these terms out of the root. How we will do that? We will use the rationalization method. Let's multiply 1 plus sine A in the numerator and denominator under the root. In the numerator we got 1 plus sine A whole square, and in the denominator we got 1 minus sine square A. How we got 1 minus sine square A in the denominator? We have simply used the formula A minus B into A plus B, which is A square minus B square. So in the denominator we got 1 minus sine square A. Let's take the numerator term out of the root. The square will cancel out. We got 1 plus sine A in the numerator. And in the denominator, what is 1 minus sine square A? It will be cos square A. How? We have simply used the first trigonometric identity formula, that is sine square A plus cos square A is equal to 1. So we got cos square A as 1 minus sine square A. So we have replaced 1 minus sine square A with cos square A. In the denominator also, let's take the term out of the root. Here the square and the root will cancel out. We got 1 plus sine A upon cos A. Let's segregate the term. We got 1 upon cos A plus sine A upon cos A. And we know what is 1 upon cos? It is sec A. Further, what is sine A upon cos A? It is tan A. So sine upon cos is tan and 1 upon cos is sec. So we got our answer as sec A plus tan A, which is the right hand side equation. So we got left hand side as equal to right hand side. Got it? We have done with the sixth part. Let's move to part 7. Here sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. Let's take the left hand side first. In the numerator we are having the terms like sin theta, and in the denominator we are having cos theta. We can take sin theta as common from the numerator and cos theta as common from the denominator. Let's do so. In the numerator, after taking sin theta as common, we got 1 minus 2 sin square theta. And in the denominator, after taking cos theta as common, we got 2 cos square theta minus 1. Here 1 minus 2 sin square theta, we can write it as 1 minus sin square theta minus sin square theta. What we have done, we have simply replaced minus 2 sin square theta with minus sin square theta minus sin square theta. On adding, it is minus 2 sin square theta. Similarly, in the denominator, we can rewrite 2 cos square theta as cos square theta plus cos square theta. Why we have done this? So that we can apply our first trigonometric identity equation, which is sin square theta plus cos square theta is equal to 1. Here 1 minus sin square theta is cos square theta, and cos square theta minus 1 is minus sin square theta. So let's replace the terms 1 minus sin square theta with cos square theta and cos square theta minus 1 with minus sin square theta. Here cos square theta minus sin square theta in the numerator and denominator will cancel out with each other. We got sin theta upon cos theta, that is tan theta. The only term that we left is tan theta, which is the answer and which is equal to the right hand side. Got it? Very simple but interesting. Let's move to part 8. Sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. So this is the question. Let's start from the left hand side. In the first term of the left hand side, we are having sin and cosec. In the second term, we are having cos and sec. And we know sin and cosec both are reciprocal of each other. And cos and sec are also both are reciprocal of each other. So this is the indirect hint through which we will proceed with this question. So let's open the square term. Here a plus b whole square formula will be applicable, which is a square plus b square plus 2ab. So it will be sine square a plus cosec square a plus 2 times sine a into cosec a. And also let's apply the square formula in the second term. We got cos square a plus sec square a plus 2 times cos a into sec a. Here we can replace cosec a with 1 upon sine a and also sec a with 1 upon cos a. Got it? Cosec is the reciprocal of sine and sec is the reciprocal of cos. Here sine and sine will cancel out and cos will also cancel out with each other. So we got sine square a plus cosec square a plus 2 plus cos square a plus sec square a plus 2. Further, here sine square a plus cos square a, it is resembling our first trigonometric identity equation, which is equal to 1. Sine square a plus cos square a is equal to 1. So we got 5 plus cosec square a plus sec square a. Let's compare it with the right hand side expression, which is 7 plus 10 square a plus cot square a. And we got our expression in the terms of cosec square a and sec square a. So basically somehow we have to convert cosec and sec into cot and tan. How we can convert the cosec into the cot and sec into the tan? We will use our second and third trigonometric identity equation. The second trigonometric identity equation, sec square a is equal to 1 plus tan square a, and the third trigonometric identity equation, cosec square a is equal to 1 plus cot square a. Let's replace cosec and sec. We got this equation. Let's add all the terms. We got 7 plus tan square a plus cot square a, which is the answer, which is equal to right hand side. So we have solved this question. Got it? We have done with the part 8. Let's move to part 9, which is cosec a minus sine a into sec a minus cos a is equal to 1 upon tan a plus cot a. Hint is given, simplify left hand side and right hand side separately. So let's solve this question. Let's take the left hand side first. The left hand side is having two terms. The first term is having cosec and sine, and the second term is having sec and cos. And we know cosec and sine both are reciprocal of each other, and sec and cos both are reciprocal of each other. So here we will use the reciprocal formula. So let's replace cosec with 1 upon sine a and sec with 1 upon cos a. Let's solve it. Let's take sine a as the LCM and also cos a as the LCM. We got 1 minus sine square a upon sine a into 1 minus cos square a upon cos a. And by looking at the expression and as per the previous experience that you have got, we know 1 minus sine square a is equal to cos square a, and 1 minus cos square a is equal to sine square a. What we have done, we have simply applied the first trigonometric identity equation, which is sine square a plus cos square a is equal to 1. We got cos square a as 1 minus sine square a and sine square a as 1 minus cos square a. A simple mathematics we have applied. Further, here one sine and one sine will cancel out and one cos and one cos will cancel out. We got our answer or the expression as sine a into cos a. We have solved the left hand side. We got sine a into cos a. Let's also solve the right hand side and we will try to get the same expression, which is sine a into cos a. We are having the right hand side as 1 upon tan a plus cot a, and we have to convert this into the sine and cos term. How we will do? We know tan is sine upon cos and we also know cot is cos upon sine. So let's replace tan with sine upon cos and let's replace cot with cos upon sine. Okay. Let's further solve it and let's take the LCM as sine a into cos a. We got sine square a plus cos square a. Further, this sine square a plus cos square a, it is resembling our first trigonometric identity equation, which is equal to 1. So we got sine square a plus cos square a is equal to 1. Let's replace it. So we got sine A into cos A. That is the answer. Our left hand side and right hand side both are matching with each other. So we have done with the part 9. Interesting? Let's move to the part 10, that is the last part. The question is 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A upon 1 minus cot A whole square is equal to tan square A. Here we are having three expressions or three terms. We have to prove all these three terms are equal to each other. Let's take the first term and we will try to prove as equal to tan square A. Then we will take the second term and we will also prove it as equal to tan square A. Basically this is two questions which is combined into one question. Interesting. So let's take the first term 1 plus tan square A upon 1 plus cot square A. We are trying to prove it as equal to tan square A. It means we have to convert the whole expression into tan form. Numerator we are already having in the tan form. Let's try to convert the denominator into the tan. We are having cot in the denominator. How we can convert it to tan? We know cot and tan both are reciprocal of each other. That is cot is equal to 1 upon tan. So let's replace cot A as 1 upon tan A. We got 1 upon tan square A. Further, let's take tan square A as the LCM. We got tan square A plus 1 upon tan square A in the denominator. Here further rearrange this equation. 1 plus tan square A and 1 plus tan square A will cancel out with each other. We got our expression as tan square A, which is the answer, which is the right hand side. Got it? We have proved it as equal to tan square A. Further, let's take the middle term and let's try to solve it as equal to tan square A. Again, this is having tan A and cot A and we have to convert the whole expression into the tan form. So how we will convert cot to tan? Simple, cot is the reciprocal of tan. So let's replace cot with 1 upon tan A. Let's take the LCM as tan A. We got tan A minus 1 upon tan A in the denominator. Further, let's rearrange this. We got 1 minus tan A in the numerator and tan A minus 1 in the denominator. We can cancel out both the terms if we take negative as common from one of the terms. Let's take negative as common from the denominator. Here 1 minus tan A and 1 minus tan A will cancel out with each other. We got minus tan A whole square, which is tan square A. Got it? We got the answer as tan square A, which is equal to right hand side. So we have proved this question, that is the two terms are equal to tan square A. Got it? We have done with the part 10. So we have done with the question number 4. So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA Classes. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for and have a great day. Bye.